Hello, let's attempt this JAMB question. 50 centimeters cube of hydrogen as packed with 20 centimeters cube of oxygen at 100 degrees Celsius and 1 atmosphere. The total volume of residual gas is what? These options are given to us. After calculating, we'll know which one is correct. Now, from the question here, it is dealing with volume of gases. And this is from Lussac's law. Lussac's law states that when gases combine, they do so in their simple volume ratio one to another with respect to the gaseous volume, provided that the gases combine at constant temperature and pressure. Now, from here we have the equation between the reaction for hydrogen and oxygen. So from here, hydrogen is reacting with oxygen gas, hydrogen gas reacting with oxygen gas to produce a molecule of water. Now to balance it, at the reactant side there are 2 atoms of hydrogen, and at the product side 2 atoms of hydrogen. Then we come to oxygen. At the reactant side 2 atoms, but at the product side only 1 atom. So what do? We introduce 2 preceding water molecule. 2 preceding water molecule. Now oxygen at the reactant side is 2, and then at the product side is also 2. Let's go back to check, because these 2 here has affected hydrogen as well. 2 at the reactant side for hydrogen, and at the product side it has now become 4. So what do? We introduce 2 preceding hydrogen at the reactant side. Now let's check again. At the reactant side 4 hydrogen atoms, and at the product side 4 hydrogen atoms. It means that hydrogen is now balanced, and they will come to oxygen. At the reactant side again 2 atoms, and at the product side 2 atoms. Now this is the balanced chemical equation. Please take notes, they are all gaseous mixture and products. Now from here, according to this balanced chemical equation, the ratio is 2 molecules of hydrogen gas to 1 molecule of oxygen gas, producing 2 molecules of gaseous water. Now according to Lussac's law, this means that 2 centimeters cube of volume of hydrogen gas reacts with 1 centimeters cube of oxygen gas to produce 2 centimeters cube of gaseous water, or if you like, steam. But let's check what is given to us. 50 centimeters cube of hydrogen is given, so write 50 centimeters cube of hydrogen. Then for oxygen, 20 centimeters cube is given. 20 centimeters cube of oxygen is given. Now, from what we have here, if 2 centimeters cube of hydrogen reacts with, this is what I'm saying now, if 2 centimeters cube of hydrogen reacts with 1 centimeters cube, or combined with 1 centimeters cube of oxygen, but what is actually given to us is 50 centimeters cube of hydrogen. How many centimeters cube of oxygen will be needed? Now what we'll do is just to cross multiply like this, and then we'll be having 50 centimeters cube times 1 centimeters cube divided by 2 centimeters cube. And centimeters cube cancel centimeters cube here. 50 times 1 is 1050 divided by 2. So 2 here, 1, 2 here, 25. Therefore, it becomes 25 centimeters cube. Meaning that for 50 centimeters cube of hydrogen gas to be used, 25 centimeters cube of oxygen gas must be used for the product to be formed. That is if all of 50 centimeters cube will be used up. But what is given to us is only 20 centimeters cube. It means that for this reaction to take place, we don't have sufficient volume of oxygen gas. Therefore, we make reference to the 20 centimeters cube of oxygen gas that is given to us here. In that case, oxygen will be used to determine the reaction. Therefore, we have 1 centimeters cube from this balanced chemical equation originally of oxygen gas cube, 2 centimeters cube of hydrogen gas. But what is actually given to us here is 20 centimeters cube of oxygen gas. And this will require how many centimeters cube of hydrogen gas? So we also cross multiply here, so it becomes 20 times 2 divided by 1, all in centimeters cube of hydrogen. Finally, 20 centimeters cube of oxygen requires 40 centimeters cube of hydrogen. I hope you understand it now. 20 centimeters cube that is given to us require 40 centimeters cube of hydrogen. So if we look at this, 40 centimeters cube of hydrogen has been used up. It means that the volume of hydrogen gas will be, the portion will be remaining. Now, how do we know the volume of hydrogen gas left? It will be 50 that is given minus 40 centimeters cube. So this is 50 minus 40 centimeters cube, which is now equal to 10 centimeters cube. Therefore, the volume of hydrogen gas left unreacted, that did not take part in the reaction or was not used up, is 10 centimeters cube. Again, what is the volume of product formed? That is of the gaseous water, if you like, steam. We still make oxygen gas determinant because we are making use of this 20 centimeters cube. So, with respect to this balanced chemical equation, 1 centimeters cube of oxygen gas produces 2 centimeters cube of gaseous water. 1 centimeters cube of oxygen gas produces 2 centimeters cube of gaseous water. And what is now used by what is given for oxygen gas is 20 centimeters cube. 20 centimeters cube. So it will produce what? To produce what? We'll cross multiply. We'll be having 20 times, that is 20 times 2, divided by 1, all in centimeters cube of water. Therefore, 20 centimeters cube of oxygen produce 40 centimeters cube of water. How did we get this 40? 2 times 20 times 2 divided by 1. 20 times 2 is 40, and then divided by 1 is still the same as 40. Now, the actual question is, what is the total volume of residual gas? We must first understand what residual gas is. Residual gas is the total mixture of gas that is left unreacted, unused. All the total gas that is left at the end of the reaction. So, total volume of residual gas is equal to 10 centimeters cube of hydrogen gas that was left unused. 10 centimeters cube plus 40 centimeters cube of the gaseous water that was produced plus 40 centimeters, all in centimeters cube. So total volume of residual gas is equal to 50 centimeters cube. So let's check. From the options here, option A is the correct answer because it is 50 centimeters cube. Thank you.